We'll get started in about 2-3 minutes. Thanks for your patience. Please mute yourself as you're coming in. Thanks. We'll get started in a few minutes. Let's give everyone a chance to get in and get settled. Patience. All right. Thanks everybody for joining in this evening. If you'll kindly mute yourself so that we don't get any like feedback, much appreciated. So just as a reminder, I am recording this session and I will share the recording when we're done. It usually takes me about a day or so to get the video captioned, and then once that's available, I will share it out in the announcements. Okay, so I'm gonna go ahead and share my screen. Okay, will somebody kindly let me know if you're seeing the course homepage?
Yes, ma'am.
Thank you very much. Okay, so I'm gonna go into the announcements real quick because I just wanted to make sure that everybody's seeing the items that I've been putting there for you. Notice that the video recordings from our previous 2 sessions are available. And some other important announcements are available to you as well, okay? Notice the extra resources, which I definitely will be relying on here shortly. A link to the textbook, information on the class project, and then a series of recordings, and so on and so forth, right? So if you're not checking the announcements on a fairly regular basis, then you probably want to make sure that you begin doing that so that you don't miss any key items that I share with the class beyond our meeting space here. All right. So if you'll click on the weekly overviews, you notice that this week we're continuing our study of measurement. So just to kind of recap last week's meeting, last week we met and talked about the nature of science, the idea of the scientific method as a means of structuring scientific investigations and research. We talked about the connection between science and technology. And some of you were kind enough to share out some examples like the computer, which I thought was a very good example. And also, bear with me just for a second, my computer wants to give me a little bit grief here. Okay, all right, I think it's okay. All right. So as I was saying, sorry about the interruption. Some of you shared out examples of the connection between science and technology. One student talked about the computer. Another student brought up video games, and another mentioned cell phones. So, you know, those were all valid examples that explore the connection between science as a knowledge endeavor and technology, which is an application of knowledge endeavor. We also began our introduction to measurement. I shared information on the metric-based properties, those fundamental characteristics in our environment that we investigate through observation and measurement. And then we moved into a discussion of the metric units that support the measurement of those base properties: time, mass, length, and temperature, and their associated metric base units. And then we looked at how we can make multiples or fractions of our base through the use of metric prefixes and their associated powers of 10. And finally, we ended the night with a discussion of derived properties like volume and the appropriate units that can be used to measure volume. And then finally, density as a derived property and the units that can be used to measure density. And we looked at 3 examples of utilizing the density formula through a construct that I like, which is called a problem-solving pyramid. So that's the items that we covered last week. So this week is a continuation of our study of measurement. And so you see here, the focus tonight is on converting from, you know, one unit system to another. And then also, you know, method that we can use called dimensional analysis, which will allow us to make any type of conversion. And then we'll look at some simple, some sample problems. I like to say simple, but you know, that I guess that really does depend on the perspective. But we'll be looking at some problems that you know, will help us to clarify the whole business of unit conversions. Okay, so you can see all of the things we want to cover this week represented in these objectives. Let's take a look at the activities that you have on your plate for the week. And so you see here, you have another discussion that you'll do. This one relating to measurement, the measurement as we're dealing with it tonight, in particular unit conversion, which is due on Saturday. You have your first problem set that is due on Saturday. And that problem set actually deals with last week's material. And I mentioned it last week, that the idea that problem sets always lag a week behind. So for example, last week we covered the nature of science and an introduction to the metric system. That's what problem set number 1 is on. And then next week you'll have problem set number 2 that deals with the stuff we're covering tonight. So the discussion is always on the current topic. The problem set is always on the topic from the previous week. That's how things are structured. As always, I have a link to information on how you submit your assignments to me. And most of you are doing quite fine with that by emailing them out to me, and I appreciate that. And then if you have questions that you want to field or put out there for your classmates to respond to, you can click on the class questions link and leave your item there. And then I made available to you here in the activities and assignments a link to the useful links that deals with the sample density problems, because in your problem set 1, you will have some practice problems that deal with the density formula. And so if you wanted to have some additional practice with the density formula before you have to do the problem set, you could actually click on that useful links item and it'll take you to some practice problems that deal with density. Okay. So any questions so far on what we're covering or the items that you have to complete by this Saturday? All right. The next item that you find in the weekly overview is a set of resources that relate to the topic that's being covered. Okay. So in the announcements, there's a link to the full textbook. But what I did was I broke the textbook down by chapter and I put it in the appropriate overview. So chapter 1 in your CK-12 textbook deals with measurement. And so what you want to do is go and review that material. And, of course, it goes without saying that anything you're working on, if you have questions, feel free to reach out to me. So if you're reading in that CK-12 textbook and something doesn't make sense to you, please don't hesitate to reach out to me so that I can, be of assistance to you with your questions. There are some videos on measurement that are available to you right there under required readings. And then the supplemental notes I'll get into those briefly tonight with you as, as an introduction to unit conversions. And then I'll go into our extra notes and use that also to look at some examples, okay? So what I tell students is typically before you start trying the activities, look at the items under the required readings and viewings. That way, if there are any kind of concept, things that aren't clear, or if you've looked at an example in a textbook and that's not clear, let's get that cleared up before you try to do the homework, right? That would be a smart thing to do. Ask a question about how you solve a problem, or, if you have a question before you attempt something that you've got to turn in for credit. All right. So with that being said, let me ask once again, before I jump into this, are there any questions on anything that I've, shared out so far?
No.
Thank you. Thank you for responding. That always helps me to get feedback from the audience, to give me like an all clear to keep going, right? I don't want to just, I tell students it's useless if I'm here explaining things and you're still wondering about, well, what did she mean 5 minutes ago? That's of no use. So at any point while I'm covering this stuff, please don't hesitate. Just unmute and stop me. Say, hey, Dr. I got a question, and we'll deal with that. Okay. All right. So if you recall last week, I mentioned the idea that a big part of this whole measurement process is that effective communication, right? Because we want to have consistency when we measure, and we want to be able to communicate clearly what our measurements represent. And so in many instances, especially for folk who reside in this country, you'll have to do some type of conversion, because you might be conversing with someone who does not utilize our measurement system in the United States, the English system. Most countries in the world are using the metric system. And while, pretty much anything that we utilize on a daily basis, if you look at labels, you'll see that there are metric units provided, but it's just because, our way of living, we don't really jump into that too much. I mean, they give the example here of wanting to get gas, and if you're in Europe or in Spain, as mentioned here, you wouldn't be buying gas by the gallon. You'd be buying it by the liter. But I guarantee you, if you walked out to the pumps here in the United States tomorrow and they changed everything to liters, you'd be like, I have no clue. I don't know how much gas is 5 liters, but I know 5 gallons, right? So see, that whole conversion business is what allows us to have a clear understanding of the physical property that we're measuring and the unit that goes along with it, okay? And sometimes to communicate, we have to convert. And so that's why it's important for you to understand, because remember, everything you do in this class is based on measurement, which means everything deals with units, okay? So what we want to focus on right here in this information that's provided is the whole concept and thought process behind converting. And then we'll look at some examples where you actually convert. Okay. So when you convert, what you're doing is taking a measurement and changing it into an equivalent measurement in another unit system. Okay. And I say another unit system, that's one, that is, you know, if you are transferring from English system to metric or metric to English. Now, of course, you can do conversions within the English system, you know, 12 inches equal to foot. You can do conversions within the metric system, 100 centimeters equal a meter. And so what I want to focus on with you is the broadest type of unit conversion technique. I call it the dimensional analysis technique. Okay. Now, let me say this up front so that everybody, you know, watching this video, whether you're here now or you watch somebody watching it later, if you are comfortable doing unit conversions, you've been doing them before because maybe your job requires it, or you learned it in high school, or, you know, you had a math class recently and that's one of the things you learned. I'm not here to tell you ignore all of that and do it my way. Not at all. If you have a technique for doing unit conversions that you are comfortable with, use whatever technique you are most comfortable with. The only requirement is that you show me your work. That is a requirement across the board, whether you're doing a discussion or a problem set, that you give, you know, you show your work and you give complete responses. So on any problem set, on any discussion, anytime you've got to answer something for me, I want to see the work. I want to have everything spelled out, because this class is not just about do you get the correct answer. This class is also about what process did you follow to get to that answer. Okay. So it is a requirement. And if you check the syllabus and you've looked at the problem set and discussion requirements, it tells you that I'm looking for you to show your work. You can do the conversions any way you want to. Show me. All right. And so whenever you're engaging in this unit conversion business, what you are doing is you are taking a measurement and transforming it into an equivalent measurement in another unit. Okay. And so in order to do that, you have to understand a couple of things. Number one, when you go through the process of doing a unit conversion, you need a conversion factor. Okay. And you find these conversion factors in charts or tables. And here's an example of one right there in the link that I clicked on in my supplemental notes. Okay. So this is an example of a chart where you have units and their equivalents. So for example, 4 quarts is equal to 1 gallon, or 1,000 meters is equivalent to 1 kilometer. And so you find these conversion factors that you need to use to do conversions in these kinds of charts. So if you are doing homework or anything for me, you are free to use a conversion chart. You could use this one if it has what you need. Or if you have an old science book, maybe in a front or back cover, there's conversion charts. You're free to use those as well. But also, if you go under useful links in the course, the very first item is a unit conversion tool. Well, that attribution link is really not for you. You don't have to worry about that. But that unit conversion tool, link number 2, if you click on that, See, there's conversion factors of every kind available to you. I mean, more things than you ever probably convert in here, okay? So for example, here's a volume conversion chart. So if I'm, for example, 1 dry pint is equal to, you see liter on the other side, 0.551 liters, dry volume, okay? And then, you know, you have other kinds of conversion charts here, temperature, pressure, all kinds of things. So 1 Kelvin is equal to negative 272.15 Celsius, right? So you are free to use this conversion chart that you have access to under useful links anytime you're doing a problem set, okay? Or even on exams, if you need specific conversion factors, I will either provide them to you or provide you access to a conversion chart that has those conversion factors available, okay? I always tell students that the issue might not be having a conversion chart available. The issue is most likely for a lot of students, what do I do with it once I have it, okay? So in order to do a unit conversion, you need a conversion factor, which you can find in conversion charts or tables. But what is a conversion factor? Well, this conversion factor is no more than a fancy way of writing 1 that allows you to convert from one unit to another, okay? And that shouldn't be a difficult concept to understand, because you learn very early on in your educational life that if you multiply or divide by 1, you don't change the value. So if a conversion factor is just a fancy way of writing 1, and when you multiply or divide by it, you don't change the value, you just change the unit that measurement is being expressed in, okay? Any questions about that?
Not yet.
Not yet. Okay, I like that response. That's a very valid response. Not yet. Let's see what comes down the road, and then we'll see what kind of questions come up, right? Okay, so here in this material, we'll look at some examples of conversions and some various ways that you might attempt to do a unit conversion. But then when I go into the other examples from the extra notes, I'm going to focus on the technique that I like best, which is dimensional analysis, okay? So they give an example here. They want to know how many cups are in a gallon. So you have a gallon of milk, for example, and you want to know if you had to pour that gallon out into cups, how many of them would you have, right? And so you need a conversion factor. You need a conversion factor that will tell you the relationship between cups and gallons. Now, see here on this conversion chart, we don't have cups to gallons. We have cups to pints, right? And so that highlights something very important about using a conversion chart. A chart is going to be limited. It's not going to have every conversion factor under the sun. Okay, but it's going to have logical conversion factors available to you, okay? And so you can see they go from cups to pints, and then pints to quarts, and then quarts to gallons, okay? So we can then take that and utilize the fact that there are 2 cups in a pints, 2 pints in a quart, and 4 quarts in a gallon. Now, I have yet to write the publisher on this because they made a big snafu on their typing right here. You see, that should actually be quarts. And that is because what you have to do when you do a conversion is you have to line up your conversion factor so that you cancel out like units. Okay, because units can be canceled just like variables. Okay, and so we started out with we want to know the idea of how many quarts in the gallon, cups in a gallon. So we start out with 2 cups and 1 pint, and then we multiply that by 2 pints and 1 quart. And then finally, that should say 4 quarts per 1 gallon, okay? And so that means then we can cancel out our pints because we have like units there. We can cancel out our quarts, provided we fix their typo, cancel out the quarts. And then what you have to do is multiply all your top numbers, multiply all your bottom numbers, then divide. So that becomes 16. And you want to then divide, because you have on the bottom here, you're writing it as a fraction, 16 cups per 1 gallon, okay? So if you were to take a gallon of milk and fill out your standard size cup, then you would get 16 of them, okay? Any questions on that example?
No.
Okay, so we'll look at another way that they are solving the unit conversion, doing a unit conversion. And this might be a technique that some of you use. And again, I'm not here to tell you that you can't do that. Only thing I'm saying to you is whatever technique you use, you have to show your work, okay? It has to be evident to me what you're doing, okay? So it says, another way to solve the conversion factor problem is by using a ratio, okay? And so the question here is how many feet are in 16 yards, okay? So you have 16 yards, and that probably can resonate with some of you because yards is something we use in the football game, right? 16 yards, it's like, Mahomes has 3rd and 16 and he throws an interception, whatever, okay? So how many feet are there in 16 yards? So we're starting off with our 16 yards, but what we want to end up with is an equivalent in feet. So they set this up as a ratio, and they are using the conversion factor right from the chart. You see here, 3 feet is equal to 1 yard. So they said here, 3 feet is to 1 yard as, that's how you read that, right? That equal sign, as X number of feet is to 16 yards, okay? 3 feet per 1 yard equals to how many feet per 16 yards? And then to solve that ratio, you cross multiply, okay? So 3 feet times 16 yards equals to 1 yard times X number of feet. And the whole purpose here is to get the X by itself, right? So X would then be equal to 48 feet yards divided by 1 yard. And so the yards will cancel, and then you're left with 48 feet. So if you had 16 yards, you would have the equivalent of 48 feet. Now, I will say to you up front, if you're solving this and you're using, some people just say, okay, I gotta take the 16 and multiply by 3. As long as you showed me that kind of work, I would be okay with that, okay? I would be fine with that. But the idea is that you can't just write 48 feet. You have to show me something, okay? Does that make sense to you? My student who said so far or not yet, how you feeling now? You feeling okay about this?
Yeah, I'm good.
All
I
right.
just didn't want to answer for everybody.
No, I get it, and I'll be honest, You know, sometimes I wish students would be more vocal. It's perfectly acceptable, but I get it. If you don't say anything, then you know, the only thing I can do in that case is to assume that you're okay. And sometimes assuming is all right, and sometimes that gets us in the hot water. But I appreciate you letting me know that right now everything's a-okay. All right. So what I want to do now is I'm going to go right into the other resources that I have available for you. Let's close that down. Okay, and in the announcements, if you recall last week, I went into a folder that said extra resources. Okay, so in the announcements, there's an announcement that says extra resources. And what this does is it takes you to a folder that has a folder for every topic that we cover in this course. Okay. Let me I don't know, let me see if I can delete that one because I don't like students to go look at that because that's old. But here, measurement. Okay. And so last week, we actually went through the nature of science, an introduction to measurement, and then units and measurement, SI-based units and prefixes. This week, we're going to focus on unit conversions. Okay. And I'll spend a few minutes talking about what they call here this SI prefix conversion technique. Oh, sorry. Didn't mean to do that. Let me just move this over a little bit. I'll spend just a few minutes talking about that because actually what that technique does is it allows you to make metric conversions, metric to metric, right? But we're going to focus on the dimensional analysis technique in a much deeper way because with that technique, you can do any kind of conversion. All right. So I'll just briefly mention this SI prefix conversion method. Okay. So this SI prefix method allows you to convert from one metric measurement to an equivalent metric measurement by looking at the exponents that go with the prefixes. And then you just move the decimal point to the left or right, depending upon how many decimal places. Now, some of you have, it's a chart of some type, and it tells you all the different prefixes, powers of 10, and then, you know, you can count which direction you need to move and right on that chart. That is really fine if you want to use that. I have no issue with that at all. You just have to, you know, give me some idea of how you're moving the decimal point or something like that. So I know if that's how you're doing your metric conversion. Okay. I'm perfectly comfortable with that. But you don't necessarily have to use this technique, but you do have to show me something. And so, for example, they give 532 meters is equivalent to 0.532 kilometers. So the question is, how did they know to move the decimal point 3 places to the left in this instance to get kilometers? And this is what the concept that they're using. Okay. Now this is the same metric prefix chart that I shared with you last week, but notice off to the left side, it has the arrow set that say move to the left or move to the right. And so it's telling me, for example, that if my exponent is getting more positive, then I move my decimal point to the left. So if I am going from centi to mega, for example, I would be moving my decimal point to the left. And in that particular case, since I'm going from centi to mega, you can see that there are 8 decimal places. From -2 to +6 is 8 decimal places. So I would be moving my decimal point to the left 8 places. Okay. If I'm going from centi to mega. If my exponent is getting more negative, then I move my decimal point to the right. So if I'm going from kilo to micro, I move my decimal point to the right. How many places? Well, from kilo to micro, you can see there are 9 places, okay? From +3 to -6, there's 9 places. So I will move my decimal point 9 places to the right, okay? And some of you have some charts that are similar. Feel free to use those. You know, if you're just relying on moving the decimal point to the left or right to do a metric conversion, I'm fine with that. Just again, tell me how many places you move in which direction. That'll be fine for me. Something to show me that you know what you're doing, okay? And they even have some examples in this packet with the answers given. So what I always tell students is you should take a few minutes and try these examples and see if you understand how they got the answers that they did. Okay, these are some freebies that you can practice with, okay? In fact, what I wanna do before I jump into some more examples using a dimensional analysis technique is let's take maybe 5 minutes, okay? So it's like 6:06. Let's say in 5 minutes, 6:11, 6:12, we're going to reconvene, and that'll give you time to try just you know, you don't have to try all 4 of them, but try a couple and see if they make sense to you. And when we reconvene, if you have a question, let's take a look and make sure you're okay. All right. So let's take 5. I'll cut the camera off. Let's see. There we go. Stop my video. And then in 5, we'll reconvene and we'll talk about these 4. Make sure you're on the right track there. And then we'll jump into the dimensional analysis technique examples. All right, everybody. Thanks for hanging in there with me. So, questions? Anybody look at these four, try a couple of them, and maybe have a question or two that we could explore to make sure that, you understand how they got these answers. All right, well, that sounds good. I'm glad that that made sense to you. So now let's get a little bit deeper into the dimensional analysis technique. So the main idea here when you do the dimensional analysis technique is that you can cancel out like units. And we saw that in the examples that I worked from my notes. And we rely on that idea in order to convert, within the metric system, or from English to metric, metric to English, within the English system. When we use the dimensional analysis technique, we're relying on the fact that our conversion factor will allow us to cancel out like units. Okay. And so this is kind of the thought process that you go through when you use the dimensional analysis technique. So you have to be clear in your mind what unit you're starting with and what unit you want to end up with, right? There's no point in doing a unit conversion if in the end you don't get what you want, right? I mean, you have to, you have to be clear in what are you converting to, all right? And then you have to get, identify the proper conversion factor or factors. And then you line them up so that the units cancel out. The like units cancel out, multiply the top numbers, multiply the bottom numbers, then divide. You notice step number 3 here says multiply all top numbers and divide by each bottom number. What I do is I multiply all the top numbers, multiply all the bottom numbers, and then divide. Now, in many instances, you'll be dealing with ones, but that's still, if you adhere to that way of operating, you limit the chance for making mistakes, okay? And then finally, of course, you want to check the number and check the unit. Did you in fact get the unit that you want, and does your answer make sense, okay? So as I mentioned, this conversion factor is a fancy way of writing 1. So here's an example of a conversion factor. 1 inch is 2.54 centimeters. That's in the textbook, they put 1 inch is equal to 2.2 centimeters. I wouldn't penalize you either way, because if you pull that from the textbook, great, okay? But if you use this one, fine, okay? That's why I said what I'm looking for is the process that you're following, okay? So 1 inch is equivalent to 2.54 centimeters. So if I divide 1 inch by 2.54 centimeters, I get 1, because they're equal to each other. But notice how that conversion factor is lined up. It is lined up in this case with the inches on the top and the centimeters on the bottom. So if I use the conversion factor lined up this way, it means I'm trying to cancel out centimeters and keep inches. Now, that's the way we'll operate in this class. We try to keep it, since this is an introduction, we try to keep it the process basic, because I could get into doing conversions where you're dividing by your conversion factor and so on and so forth. But just to give you some familiarity with the process of doing unit conversions, we're going to stick to, you line up the conversion factor so that you cancel out the unit in the denominator and keep the unit in the numerator. So if it's lined up like it is here on the first one, you're canceling out centimeters and keeping inches. Notice on the bottom here, example, we took that same conversion factor. 1 inch equals 2.54 centimeters. But this time we lined it up with the centimeters in the numerator and the inches in the denominator. So if it's lined up like that, it's still equal to 1. But what we're trying to do with it lined up this way is cancel out our inches and keep our centimeters. So having a conversion factor is very important, but it is equally important that you line it up the correct way so that you cancel out the unit you have and keep the unit you want. Cancel out the unit you're starting with and keep the unit you want to end up with. Okay? That makes sense to everybody?
Yeah.
Okay. So now let's get into some examples. So I'm going to work several examples for you. And at any point, if something's not clear about why they did what they did, let's stop and talk about it. Make sure we're all good. Okay. So we'll start off with a fairly straightforward example. It says your European hairdresser, because we all have one of those, you know, wants to cut your hair 8 centimeters shorter. How many inches will he be cutting off? So I'm not, you know, if I were going to the barber shop in Europe and Fabio said he wanted to cut off 8 centimeters of my hair, I would have to tell him, hold up, let me pull out my handy dandy converter and figure out how many inches that is, and then we can go from there. Okay. So I like the way they set this up, because you can clearly distinguish the measurement that you have when you start. You can clearly identify the conversion factor. You can easily see what units need to be canceled, and then you can move forward, right? So the measurement that you have, in this case, 8 centimeters, notice is written, you know, kind of by itself with nothing underneath, the measurement that you have. And then notice they lined up the conversion factor. 1 inch is equal to 2.54 centimeters, but they lined it up with the centimeters in the bottom because that's the unit we need to cancel out. Okay. Notice if you accidentally flip the conversion factor and you put the inches on the bottom, there's no way for you to, you know, figure out the inches that you have, because you'll in essence be having some crazy thing, centimeters squared per inch, and that makes no sense, right? So I always tell students, slow down just for a moment, make sure you lined up the conversion factor correctly, cancel out your like units, multiply all your top numbers, and then in this case, divide by your bottom number. So 8 inches per 2.54, because the centimeters cancel out, will give you 3.15 inches. Okay, so 8 divided by 2.54, 3.15, 2 decimal places is more than sufficient. Centimeters are gone and you're left with inches. So if you had an 8 centimeters, the equivalent would be 3.15 inches. Does that make sense to everyone?
Yep.
Cool. All right. Now let's look at one that requires a little bit, you know, more to it than just a one-step process. So here we have how many milliliters are in 1 quart of milk. So you have a quart of milk and you want to know how many milliliters can you fit in there. Okay. So what we need is to be able to get rid of our quarts and end up with milliliters. Okay. So we're starting out with 1 quart. But notice the first step that's taken does not convert from quarts to milliliters. It only converts from quarts to liters. Remember I said on a conversion chart, they won't have every conversion factor. Many times a conversion chart will have the most logical conversion factors. In this case, 1 liter is equivalent to 1.057 quarts. Okay. So after you take that first step, you will cancel out your quarts. Now you will have the equivalent in liters, but they didn't ask for liters. They asked for milliliters. So we need to do an additional step to convert our liters to milliliters. And so if you look on a conversion chart, you'll see 1,000 milliliters is equal to 1 liter. And so now we have to line up that conversion factor so that we cancel out our liters and keep the milliliters. So see, to do this conversion, because of the conversion factors that you had available, logical conversion factors. And when I say logical, meaning those two units are pretty close in size. A quart and a liter are pretty close in size. So that's why that's a logical conversion, okay? And so once you've done that, then you multiply 1 times 1,000, and you divide by 1.057. That'll give you 946. And the unit left after you cancel out all like units is milliliters, okay? Now, this type of example, some students will feel comfortable breaking it down into more than one step, and that's perfectly fine. There's nothing that says you have to write it all in a row just like that. You could, the first step could be converting your quarts to liters, and the second step can be converting your liters to milliliters. You could break it down in 2 separate parts if that's most comfortable to you. If you had a conversion factor that went directly from quarts to milliliters, you could do it in 1 step. Just depends on what conversion factors you have available, all right? What are your questions about this second example?
None at the moment.
Okay, great. This next example, it says, assume your mass is 55 kilograms. How many pounds do you weigh? Now, I talked about this last week that technically pounds is weight, but there's something going on behind the scenes that allows us to convert from kilograms, which is mass, to pounds, which is weight. And that is the fact that on this planet, gravity is fairly constant, about 32 feet per second squared. Pretty constant, pretty, you know, that's a nice average value. And so there's a kind of an equivalence between mass, kilograms, and weight, pounds. And that conversion factor is 2.2 pounds for every 1 kilogram. Okay. So we're starting off with 55 kilograms, and we want to know what's the equivalent measurement in pounds. So I'm going to take my conversion factor, 2.2 pounds per 1 kilogram, and line it up so that I cancel out the unit I'm starting with, in this case, which is kilograms, and keep the unit that I want to get to, pounds. So when I line it up with the pounds on the top and the kilograms on the bottom, my kilograms cancel out. I multiply my 55 times 2.2, that's 121. And my unit in this case, pounds, okay? So again, you take the measurement that you're starting with and you multiply it times 1 in the form of a conversion factor, and you get the equivalent measurement in another unit, okay? How about this example here? Does this look pretty good to you? Any questions? All right, appreciate it. Let's take a look at another example. So it says, how many feet long is a 5K, which means 5 kilometers? I had to tell a student, they're not talking about 5 Kelvin. This K stands for kilometers. A 5 kilometer race, okay? And so in this particular case, we're taking our 5 kilometers, and when we finish converting, we want an equivalent measurement in feet. Now, this is a multi-step process because I don't have a conversion factor that goes straight from kilometers to feet. I do have a conversion factor that takes me from kilometers to miles, and then another conversion factor that takes me from miles to feet. So I have to take my first conversion factor and line it up so that I get rid of my kilograms. When I finish the first step of this problem, I will no longer have kilograms, sorry, kilometers. I will have miles. Okay. So I get rid of my kilometers, and then I'm working with miles after the first step. And then I'm going to take those miles and convert them to feet in the second step. So 1 mile is equivalent to 1.609 kilometers. I lined it up so that I cancel out my kilometers. And then I take 5,280 feet per 1 mile, and I line it up so that I cancel out my miles. Everything canceled out except feet. I multiply 5 times 5280 and divide by 1.609, 16,408 feet. So if I'm running a 5-kilometer race, I'm running the equivalent of 16,408 feet. Okay. Does that example make sense to you?
Yes.
Thank you, Mr. Jackson. I really appreciate it. Again, let me say this because I know that some of you are probably looking and saying, "Okay, I'm familiar with unit conversions. I wouldn't necessarily do it that way." And guess what? I'm perfectly fine with that. I'm fine with you doing it whatever way is most convenient for you. The only thing I request is that whatever technique you use, you must show me your work. You have to show me. Let's take a look at one more. So that's how many grams does a 10-pound bag of potatoes weigh? Okay, so in this instance, we're starting out with pounds and we want to end up with grams. In the previous example, we started off with kilograms and we ended up with pounds. But in this case, we're going to start with pounds and end up with grams. So, well, first thing we have to do is we have to take that 10 pounds and convert it to kilograms. So remember from our previous example, 2.2 pounds for every 1 kilogram. But notice in this case, I lined it up with the pounds on the bottom. Okay, because I'm trying to cancel out the pounds. In the previous example, it was lined up so that you canceled out the kilograms. So you have to be sure to line it up to cancel out the unit you have, in this case, pounds. Now, once I'm finished that first step, I won't be done because they didn't ask me for kilograms. They asked me to figure out how many grams in this instance. So I need a second conversion factor, and that is 1,000 grams for every 1 kilogram. Okay. And so now I'll take that conversion factor and line it up so that I cancel out my kilograms. Okay. And again, I don't expect you to memorize these conversion factors. I expect you to use the resources at your disposal so that you can complete these questions, or these questions or any questions that you're asked. Okay. And I always tell students, you are perfectly free to print out all of these extra notes, print out all of the notes that are in the weekly overviews, print out whatever it is you feel like you need and use it, even when it comes time for exam. Okay. So when you finish this problem, you have to take 10 times 1,000 divided by 2.2, and that comes out to be 4,545. And the only unit you have left after you cancel all like units is grams. And that is the unit that you're looking for. Okay. All right. Questions on number 7 here. All right. And then let's do one last example. And if you don't have any questions, we'll call it a night. So it says here, Taft football needs 550 centimeters for a first down. How many yards is this? Now, I have no idea where Taft is located at, but if they're measuring things in centimeters, they aren't in the United States. Maybe this is rugby, you know, in Canada or overseas in England somewhere. But 550 centimeters, I would need to convert that to yards for it to make football sense to me, right? So I'm going to convert the 550 centimeters into its equivalent in yards. So I don't have a conversion factor that goes directly from centimeters to yards. In this instance, I have to do 3 steps because I first need to convert my centimeters to inches, then my inches to feet, and then my feet to yards. Okay. So 1 inch for every 2.54 centimeters, I can cancel out my centimeters. 1 foot per every 12 inches, I can cancel out my inches. And then finally, 1 yard per 3 feet, I can cancel out my feet. So if I line up my conversion factors correctly, I cancel my centimeters, I cancel my inches, I cancel my feet, and I'm left with yards. Multiply all the top numbers, multiply all the bottom numbers, then divide. Okay. I always say that because some of you have those fancy calculators where if you know how to group things, fine. But if you don't and you multiply the, you try to do the multiplication and division, you group things incorrectly, you get the wrong answer, right? So 550 times 1 times 1 times 1, and then multiply 2.54 times 12 times 3, and then divide. And I'll give you 6.01 yards, okay? What are your questions on this last example that I've worked?
Speaking for myself, I pretty much got it. I think I understand it.
Okay, Mr. Jackson, I really appreciate that. Anybody else out there working, if at any point you have questions about these examples or the ones that you have to, deal with in your assignments, please don't hesitate. As soon as this video is captioned, I will make it available in the announcements. And I appreciate your attention this evening, and you asking, Mr. Jackson, especially being so responsive to me. If there are no further questions, we are done for tonight. And I appreciate you joining. See you back here next Tuesday, right at 5:30.